Hello and welcome to this episode. So I'm trying to make this the last but one video that covers what we need to know about NumPy. And so after this video, I'm going to make another video that will show you how to perform the linear algebra operations that are related to building deep neural networks with Python so that we can actually start building our neural networks from scratch using NumPy. And so, as you can see, this video is going to focus on comparison operators and Boolean masks. Up until this point, we've learned how to create different types of NumPy arrays. We've learned how to index into them. We've learned how to fetch and set items in these arrays. But one thing we don't know how to do is to select items or change items based on certain conditions or criteria. And that is what Boolean mask allows us to do. So you basically create a mask and you can either get the indices of that mask or you can use the mask to select sub-components or sub-items from a given list. So let's start off by creating an array that starts from 1 to, let's say, 10. I'm going to print this array so that we see what's in there. So it starts from 1 to 9. Always remember that the last digit is not included. Okay, so it is 1 less than the last integer that you specify. So we have the numbers 1 all the way to 9. Now the question is, how do we select all numbers that are greater than, let's say, 6? The way to do that is you create a mask. So I'm going to create a mask, and then I will say a mask where A is greater than 6. So basically what's going to happen is NumPy is going to go through this A array, and the mask is going to be a Boolean array where there is true or false in the index that's where the condition matches. So whether the condition is true for that particular item or false, you would have a Boolean in that place of the mask. So basically I'm going to do this, and then we'll print our mask, and then you see what's inside mask. So you can see that mask has false, 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 true, 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 because everything that comes before 7, 8, and 9 is less than 6. And so the condition where we are trying to get all items in the array where they are greater than 6, all these preceding indices do not match because 1 is not greater than 6, 2, 3, 4, 5, and 6 itself is not greater than 6. So only the items in these indices that match is what will be set as true in the Boolean mask. And I am using one-dimensional arrays for these examples so that it is easier for you to understand, but it works with any n-dimensional array. So you can use it on 2D arrays, 3D arrays, and on any n-dimensional array that you have to work with. Okay, so now we have our Boolean mask. How do we go ahead and then use it to select the things that we are interested in? Because this is a Boolean array and that is not what we are interested in. What we are interested in is all items in the array A which are greater than 6. So the good news is you should remember from the previous videos that you can supply a list of indices to use for subselection in a NumPy array. And in Python, the false, or specifically in NumPy, false is going to be treated as 0, and then true is going to be treated as 1. I'm going to tell you more about this in a few minutes. Okay, so now we have our mask. How do we go ahead and then use it to select these items from the array? It's as simple as saying array and then you pass in the mask. So basically what is happening is NumPy is going to use this mask, the Boolean mask, to determine which item at which index it should return. So the indices that were true, which is 7, 8, and 9, are what have been returned here. I don't want you to confuse this 7, 8, and 9 with the indices. These are the actual data items that are in there. To make it more concrete, I'm going to create an array that isn't sequential so that you understand things better. So I'm going to say data is equal to np.array, And what I'm going to do here is, I mean, okay, I can even still use a. So I'm going to create another mask. Okay, I'll create a mask, and the mask is supposed to be a mod 2 is equal to 0. So I'm basically looking for all entries in A which are even numbers, because if you divide them by 2, then the remainder is 0. Okay, so now let's print out our mask and see what we get. So printing out mask shows us that 2, 4, 6, 8 are true. Okay, so now let's use this mask to select from A all the even numbers, and it is as simple as I showed you above. You can store the resulting array. So you can say even nums is equal to A, and then you pass in the mask. So basically, if we come here and we print even nums, it's just going to be those items in A which are even numbers. So this is basically one simple way of indexing into your array, okay, using a condition. Okay, so the next thing I want to show you is, sometimes you are not interested in the actual items that match your condition. Sometimes you're simply interested in how many of those items match the conditions that you are looking for. For example, I know that A contains 1 2 3 all the way up to 9, and I have a mask here. This mask right now helps me to select the items that are even numbers. What if I didn't want to do a selection? I just wanted to know the count, how many of such items are in my array. It is as simple as doing mask.sum. So if I do mask.sum, I get 4, which unsurprisingly is the length of the array we got after doing the selection. And the whole idea is, in Python, the false is going to be treated as 0 and true is going to be treated as 1. So basically what you are seeing here, this false, true, false, true, false, true, false, true, false, is the same as 0 1 0 1 0 1 0 1 0. And so if you find the sum, I have shown you these unary operators in a previous video. So if you find the sum of an array that has 0 1 0 1 0 1 0 1, is going to return 4, because it's just going to perform an addition, and because zeros do not contribute to the addition, it is only the ones that are going to be counted. So this is a simple way of knowing how many items in an array matches the condition that you have set for yourself. Okay, one other thing that I want to show you is, so the mask returns a Boolean array which has true or false in the array, and it determines which indices are going to be selected when you use for selection. Okay, that is great. What if you are interested in the indices itself and not just the Boolean array? What you can do is, over here I know that 2 4 6 and 8 are the items in ARR which are even. What if I am not interested in the items themselves, but I'm interested in the indices of those items? Maybe I want to change all even numbers in the array to 0. How can I do that? So the way to do that is, you can say mask.non0 and see what this returns. This is going to return a tuple, and the first item in the tuple is going to be an array of indices that match that condition. So basically it's telling us that whatever is in A index 1 matches the condition, whatever is in index 3 matches, index 5 matches, and index 7 also match as well. So this is how these are some of the ways in which you are able to use Boolean masks to do your selection. If you know SQL, then this is kind of similar to using a select where. And the good news is that NumPy has its own where, which kind of does what the non-zero function you make, the non-zero function call you make on a mask actually does for you, and it's much simpler. But before I show you how to use the where function, I'm going to show you how you can combine multiple conditions. Okay, so I'm going to print out our array again so that we know what's in there. So our array is made up of 1, 2, 3, 4, 5, 6, 7, 8, and then 9. What if I'm interested in not just in even numbers, but I'm also interested in any number that is greater than, let's say, 5? How am I going to create the mask for that? This is how you go about it. So I'll say mask is equal to array. I'm going to combine multiple conditions, so I'm using the brackets to make it explicit so that the order is as defined by myself. So I'm going to say array mod 2 is equal to 0, and if I want to do and, I just use one ampersand, and then I want where array is greater than 6. So basically what this mask is going to return is a mask of all the indices where these two conditions are met. Mind you, I am using and, so it is not going to be it's not going to match where the item is an even number or greater than 6. It is going to be where the item is an even number and greater than 6. So let's go ahead and then print our mask to see what's in there. So you can see that at this point, the only item that matches is 8. Why? You may ask, isn't 2, 4, and 6, aren't they even numbers? Indeed, they are. But the condition here is and. So it needs to match the left and it also needs to match the right. So basically what we are trying to say is you need to be an even number and you need to be greater than 6. So that is why we got only 8. And so if I go ahead and then I use this mask to select from A, you see that we get 8 as the only item in the array that matches this condition. We can also use or. So to use or, this is how you do it. You use a pipe character, and I'm going to print our mask now. So you can see that now a lot more are going to match because it is an or. So you have to either be an even number or you have to be greater than 6. So you can see that everything after 6 matches because those items there are greater than 6, even though they are not even numbers. So know how you are able to combine different conditions or multiple conditions using the Boolean operators that you're already aware of in Python. And so I can go ahead and then I'll do mask.sum, and then we'll see that it is going to return a count of how many of such items are in the ARR, the array that we have been using for this example so far. Okay, so one last thing that I want to show you about comparison operators is the use of where. Okay, so I'm going to use the same array, and just so the items are fresh in your mind, I'm going to print it out again. So the array still has 1, 2, 3, 4, 5, 6, 7, 8, and 9 in there. Now, what if I want to use a condition to change an item? And by the way, we could also use the mask to change items in the array. I think I need to do that example before I show you this one. So if I come here and I print A, you can see that A has these items. Now if I say A and then I use mask for the selection, which means every index in the mask where it is true, I want to change it to 9. Okay, so I can come in here, and when I print A, you can see that now it is no more 1, 2, 3, 4, 5, 6, 7, 8, 9. It is rather a new array where all indices that match the condition above have been changed to 9. So I just wanted to draw your attention to the fact that this is not just for fetching, but you can also use masking for certain items in your array. Okay, now there is an alternative approach where you can index the selection by condition using the np.where. And to demonstrate that, I am going to create an array from scratch. So I'm going to say data is equal to np.arange. I'm going to say 1 to 10 once again. Okay. So data is just like the A array. I created a new one because we've destroyed it by setting all those indices to 9. Okay, so now we have an np.where function which you can use. And the way to use the np.where function is you can either supply just one argument or you can supply 3 arguments. And I'm going to show you how to use either of them so that your understanding is complete, and then we can move on to the next thing. Okay, so the way to use it is you say np.where, and then you basically bring in your condition. You can even see it from here. So you say np.where, and then you have to give a condition, and then there's x and y. If you read, it says it returns elements chosen from x or y depending on the condition. This can be a mouthful, and so I'm going to do an example so that you understand it better. Okay, so if I come here and I say let's try by saying data.where, and then I'm just going to use np.where, and then I'll say data is greater than 5. Okay, now if you use it just like this, let's see if it's going to work. Because this is Jupyter Notebooks, it's going to print out something. You can see that when you use np.where, it doesn't actually return the items of the array. It rather returns the indices that match that condition. So it is similar to calling non-zero on a mask that you have already created, like we did up here. Okay, so if you use np.where, you specify the condition, and I say I am interested in all the indices in this array where the item is greater than 5. There is another way in which you can use the np.where, and how you do it is you say np.where, you specify the condition, so everywhere is greater than 5. Now you give a value that should be yielded when the condition is true, and another value that should be yielded when the condition is false. So let's say I want every item in data, every index in data where the item is greater than 5 to be set to 1, and anything less should be set to 0. So the value to yield when the condition is true, I want to yield 1. When the condition is false, I want to yield 0. Okay, now let's see what's going to happen here. So you can see that it returns a new array where all the indices that matched this condition are set to the value to yield when the condition is true, and all the indices that didn't match are set to the value where the value to yield when the condition is false. One question you might ask yourself, is the where function changing the array in place? Let's go ahead and then see if it modified the data array. It didn't. So what it means is that the where function creates a new numpy array that matches the condition and the values that you want to yield when the condition is true or false. And I'm teaching you all these because once we begin to use NumPy to create neural networks, we will have to do exploratory data analysis where some of these things will come in handy. We will have to be changing labels, and we have to be selecting based on criteria and stuff like that. So this is what I want you to know about comparison operators and Boolean masks. Thank you for watching. Don't forget to subscribe, and I'll see you in the next video where we talk about how to use NumPy to perform the basic linear algebra calculations that we normally do in machine learning, and then we can start coding neural networks from scratch. Thank you once again, and I'll see you in the next video.